right, welcome back, everyone. If you're tackling Cambridge AS and A-level math, you already know the syllabus pulls absolutely no punches. But today we're zeroing in on the one topic that literally separates the good math students from the absolute elite. We're talking about coordinate geometry. Specifically, mastering the equation of a straight line. Now, I know what you might be thinking. Straight lines? Really? I've been doing y equals mx plus c since middle school. But trust me, the way Cambridge assesses this is a whole different ballgame. It's not just plugging in numbers, it is a massive fundamental test of your analytical thinking. So let's get into it.
Okay, let's dive right into this quote. The difference between a B and an A star in mathematics often comes down to how well you understand coordinate geometry. That is a serious statement, right? But it's directly inspired by exactly how the examiners build these papers. Mastering the straight line equation is absolutely crucial because it's the foundational language for so many other, way more complex concepts you're going to face later on. Think of it like the bedrock. If your foundation here is even a little bit shaky, well, everything built on top of it becomes exponentially harder.
So, to secure those top-tier marks, here is our game plan for today's explainer. 1. Core principles. 2. The procedural framework. 3. Top examiner warnings. And 4. The evaluation loop. Let's deconstruct the examiner's playbook.
All right, Section 1, Core Principles, Building the Foundation. Before you even touch your calculator, before you map out a single coordinate, we have to understand what Cambridge examiners are fundamentally hunting for in this part of the syllabus. This comparison right here, it brilliantly captures the entire core philosophy of the exam. Over on the left, we've got superficial breadth. That's basically just rote learning a bunch of formulas. And let me tell you, the Cambridge Assessment Framework actively penalizes that approach. Instead, they're heavily, and I mean heavily, prioritizing what you see on the right, analytical depth. Examiners want proof of a connected, conceptual understanding that you can take and seamlessly drop into a totally unfamiliar context. They don't care if you just memorize the distance formula. They want to see if you can logically apply it to some weird hybrid geometric shape you've literally never seen before. So how do we actually prove that analytical depth? Well, the syllabus lays it out clearly. You've got to master the principles through 3 key pillars. First, master precise definitions. Second, establish causal relationships, meaning you need to know exactly why step A forces step B to happen. And third, integrate with other syllabus areas. You know, principal examiner reports consistently flag that candidates who show cross-topic connections, like, say, linking coordinate geometry directly to calculus or trig, they just achieve significantly higher marks. It's all about proving you see the entire mathematical chessboard, not just one piece. Moving right along to Section 2, the procedural framework, earning method marks. Now, what's really interesting about this next part is that it's the most actionable takeaway of our whole explainer. This is the actual machinery of how you rack up points on the paper. You absolutely have to wrap your head around the method mark strategy. This is a grading system where marks are given out for demonstrating the correct analytical process, completely regardless of whether your final answer is right or wrong. Just think about that for a second. In Cambridge math, the journey literally is just as important as the destination. You're putting your logic on trial. So if you make some silly arithmetic typo on line 2, but your geometric reasoning is totally flawless, those method marks are exactly what will jump in and save your grade. To make sure you are capturing every single method mark on the table, you've got to lock in this 5-step procedural framework. Examiners are practically begging students to do this. Step 1, deconstruct the question. What is the core problem? Step 2, extract the relevant data. Pull out those coordinates, gradients, whatever they give you. Step 3, select the correct analytical framework. Step 4, execute with crystal clear notation. Seriously, don't be sloppy here. Use your headings, annotate your work. And finally, Step 5, present your answer using the precise, correct terminology. If you apply this rigorous, step-by-step structure to a complex geometry problem, you leave the examiner absolutely no choice but to award you those marks. All right, let's hit Section 3, Top Examiner Warnings, Where Marks Are Lost. Let's look at some insider intelligence directly from the principal examiner reports to bulletproof your strategy. Okay, we need to deconstruct these 3 massive traps because this is where dreams of an A-star go to die. The first classic pitfall is using the wrong approach for the context. You might have world-class algebra skills, but if you're brute forcing a geometry problem instead of using the right coordinate framework, you are going to run out of time or just get totally lost. The fix, identify and select the correct analytical framework right out of the gate.
Trap number 2, forgetting your format and presentation. Examiners honestly despise messy work. The fix here is strict adherence to conventions. We're talking proper headings, clean annotation, and the third major warning, giving answers that aren't specific to the context. You can't just regurgitate a generic solution you memorized at home. You have to mold your concepts to fit the exact, usually completely unfamiliar scenario the exam throws at you.
Listen to me, I literally cannot stress this enough, so treat this as a massive examiner alert. Students constantly lose marks simply because they don't show they're working. This right here is the ultimate golden rule of Cambridge math. Showing you're working is your absolute safety net. It's the concrete evidence of your analytical depth. If you're doing 3 steps in your head and just writing down a number, the examiner can't read your mind, right? Which means they can't give you method marks. So do yourself a massive favor, show every single step.
Which brings us to section 4, evaluation loop. Deconstruct, solve, evaluate. This is the exact blueprint top-tier candidates use to crush the most brutal, higher-order questions on the paper. Let's break down how this framework constructs an airtight mathematical argument. Securing those top marks takes way more than just isolating X. You have to navigate this higher-order framework. Most students start at the descriptive level, just stating the basic facts. Then you push into the analytical level, where you're actively processing the data. But the true A-star students, they push all the way to the evaluative level. This is the sweet spot where you are evaluating alternative methods, comparing different approaches, and actually making justified recommendations based on the geometry you just solved.
To permanently encode this into your exam day strategy, just follow this ultimate problem-solving loop. 1, identify the given information right away. 2, break the entire problem down into logical, bite-sized steps. 3, solve it systematically. And remember, show all that beautiful working out. 4, and oh man, so many people skip this. Check for reasonableness. Stop and ask yourself, does my straight line equation actually make sense given these coordinates? Like, is the gradient even pointing in the right direction? And finally, step 5, make justified recommendations if the question calls for it. So I want to wrap up by leaving you with a question to really challenge your exam strategy. In your next paper, are you just frantically trying to find the final answer? Or are you actively proving your analytical depth? Remember, the Cambridge examiners are looking for a logical, structured, professional mathematician. Lean on the frameworks we broke down today, respect the immense power of those method marks, and above all, practice these exact techniques on past papers. Thanks so much for hanging out with me for this explainer, and keep pushing for that analytical depth.